Let's go in and do a comparison between the YOLO V8, V9, V10 and also the 11 model. Then we can go in and take a look at both the pros and cons of using the different models and so on. It really depends on your application, your project, but also the type of data you have. You can use all the different tasks, so instant segmentation, object detection and all of that for all the models, and now we're just going to test it out. So first of all, we just take a look at the benchmark results on the COCO dataset. Then we'll jump into a Google Colab notebook. I'll show you how we can basically just run all the different models in a few lines, and we'll take a look at some results. So we're just going to take a video, pass it through all the models, and then at the end we can take a look at the output results, compare them side by side. So if we start inside the Ultralytics website, we can go inside our resources. We then have the docs for the documentation. When we get in here, we have this models tab up at the top where we have all the models available in the Ultralytics framework. And again, as you're familiar with, we just swap out a single line of code and we can run each of the models. So this is the benchmark results on the COCO dataset. So this is also what the pre-trained models are trained on when you use them directly out of the box or fine-tune them for your own applications and projects. So if you take a look at the new YOLO11 model, we can see it is the best here on the benchmark results. Doesn't mean that it's best on your specific data set and so on, so make sure that you test out all the different models, sizes and so on, depending on if you want more accuracy or if you want more speed. You can see we both have the nano, small, medium, large and extra large model, so make sure that you do some comparisons, model evaluations like high parameter tuning and so on. We have videos covering all of that, what it means, how you can do it and why it's also important. Down here on the x-axis, we can see the latency. So again, the closer here to 0, the faster our model is at doing inference, because this is how many milliseconds it takes to process a single image. So this is a floating point 16-bit on Tensor RT on an NVIDIA T4 GPU. So this is pretty fast. If we run with the nano small model, we can actually get down to 2 millisecond inference, and we still have pretty good results on the COCO dataset. So this is the mean error position of 0.50 to 0.95 in confidence intervals. You can see over here to the right all the models that we're comparing it to. So we have all the variations of YOLO, YOLOv5, 6, 7, 8, 9, 10, 11. So this is pretty much just the whole family of YOLO. We have YOLOx, efficient detection, and then we also have some other models as well. So if you just take a look at it, we can see that this model here is better compared to YOLOv10. It is just slightly better. So again, you need to fine tune it on your own dataset and also do model evaluation. But in general, YOLO11 looks very good, and they're also like based on some of the same things in the architecture. So let's go down and take a look at YOLOv8, maybe also like YOLOv5. So we can see YOLOv8 is a step change over V5 and also 11 over V8. We get pretty much like better accuracy on the medium model for YOLO11 compared to YOLO8, and we get both faster inference speed but also higher accuracy on our COCO dataset. Again, can be that that's not the case on your specific dataset, but again, this is just the benchmark results that we're looking at. You also need to go in and visualize it, go in and take a look at some other metrics, benchmarks, and on your own metrics when you train your own models. If we scroll a bit further down, we can then see some key highlights for the featured models. So you can read like a short description of what each of them are, and also like basically what are the features, what are the differences between those two. So this is all the models available. We're just going to test out a few, but let's now just jump straight into a Google Colab notebook. So I'm basically just going to have a video. I'm going to drop it in here in just a second. But first of all, we need to connect to our runtime. I'm going to use a GPU for faster inference speed. You can use the free GPU resources available in here on Google Colab. So first of all, let's go in and install Ultralytics. This is the only library framework dependency that we need to install. Rest will be taken care of or already pre-installed in a Google Colab notebook. Exact same way you can run it on your own local machine. So I have a video here. I'm basically just going to drop it in so we can run inference on it. I'll just show it here before. So we're going to pass this video through each of the models, V7, 8, 9, not V7, but 8, 9, 10, 11, and we can take a look at them side by side. So this is a pretty cool use case, like for traffic monitoring. We can go and like do object counting, specific zones, how many cars are going in and out, lane analysis and all that, but also just how good are the models at detecting like larger objects, smaller objects, where is it losing detection and so on. So this is a really good video to go ahead and compare it on. So after done installing here, I just have this video. Let's just rename it to road. Like that. Then we can create a new 11 model. So we're just going to use the nano model for all of them. And we can specify we have the road video instead now. So road, we want to save it so we can take a look at the results after. We're going to run with a confidence score of 0.3, image size of 640. So if you just want to do this, we can do this exact same way for all the other models. I'm just going to copy paste it. So we have YOLO10, YOLOv10, and then we have YOLOv9. And it's the exact same code. This is how easy it is to swap out the models. Also, if you have your own models, you can basically just do that on your own. Or you can just specify the path here to the PyTorch model. So now everything is installed. I can just run each of these blocks of code and we can take a look at the results after. So it's going to create an instance of our model. It will download automatically to your machine the first time. And then it's gonna just take this video, throw it through the prediction. You can specify all those different arguments and so on. We have videos covering that already. Around 15 milliseconds, 10, 20 milliseconds. 20 milliseconds would be 50 frames per second. So while it's processing this one here, I'm just going to run the other one. So we just queue all of them up. Make sure that they're running. We have YOLOv9 nano, V10 nano. So it's just gonna run all of these and also V8 at the end. So now all the videos, they have been processed. I've just exported a file here that just combines all of them. So this is just the output that we got for each individual one of them. This is the nano models and just created this side-by-side comparison. I'm just going to play it here and we can take a look at it and then basically just replay it, talk about the results and what we are seeing. So we have YOLO11 down at the bottom right corner, V10 left bottom corner, and then we have V8 and V9 at the top. If you just take a look at, like for example, the first frame, we can see that we're detecting some trucks in the YOLO11 model, which we are not doing in YOLO10. So just from taking a look at the first image here, YOLOv11 or YOLO11 looks better than YOLO10, YOLO8 and YOLO9. Let's compare those. So I think we get better results just on the first frame here. Again, we need more frames and so on. So we get pretty good results on V8, V9 and also V11. We get some trucks here that we're not getting in the other images. So let's just play it. It's flickering a bit here in the background. We're not really detecting with the 11 model. We're not really detecting these objects in the background. My experience by using the YOLO models and so on for tons of different applications and projects, I feel like YOLO11 is if you want like the highest speed possible. One has the same accuracy as the YOLOv8 model, especially like for smaller objects. But if you have larger objects, you just want to have the model to run as fast as possible. My general experience is that YOLO11 is the go-to model. If you want a bit smaller objects, you want to detect a bit smaller objects, you can go with YOLOv8. You can also, if you want very small objects and detect all cars here, you can use Saji on top of it, which is basically just sliding windows going over the whole frame and doing inference on each of them. Then we can detect significantly smaller objects. We have videos covering all these things, Saji, inference, different cases and so on. So definitely check those out as well. So yeah, we take a lot of cars here to the left. Looks pretty good. Let's just play it. Get some flickering, but in the foreground here, it looks pretty good. V8 actually gets a truck in the foreground. They also get it here in the second or at the end of the video for the other one to the right. So yeah, I think we get some pretty good results. I definitely think like 11 is significantly better than V10. I wouldn't really use V10 for this case here. V8, V9 look very similar. And again, we can see a bit small object on the V8 and V9 and then faster inference speed on YOLO11. So it depends on your use case, application and so on. This is just one test and one comparison. You need to test it out on your own data set as well. But this is like the general thoughts and also the general experience that I have with these models. It's always good to do comparisons. Make sure that you do that. Hope you learned a ton and also gotten some more insights into which of the models you should go for, but test out all of them. Hope to see you guys in one of the upcoming videos. Until then, happy learning.